In this video, I am going to solve this differential equation. By looking at the differential equation, you can see it kind of looks like an exact differential equation. The format for exact differential equation is this: p of x comma y dx plus q of x comma y dy is equal to 0. If we make a comparison between these two, we see that this is my p of x comma y and this is my q of x comma y. Now, for this equation to be exact, it must be the case, as you know from the definition of exact differential equations, it must be true that del p over del y is equal to del q over del x. So let's find these partial derivatives and see whether these two are actually equal. So del p over del y is going to be del over del y 3x square y minus cosine of x. And if you take the derivative, partial derivative with respect to y, this becomes just 3x squared, because derivative of cosine x with respect to y is 0, and when we are taking derivative with respect to y, 3x squared is nothing but a constant. Similarly, if we find del q over del x, that is going to be del over del x of x cubed minus sine of y. And of course, sine of y is a constant when I'm taking derivative with respect to x, so it's not going to change. So derivative is 0, and derivative of x cubed is just 3x squared. So these two are in essence equal. So that means we can conclude that del p over del y is equal to del q over del x. So in essence, the equation or the differential equation that we are trying to solve is actually an exact differential equation. Since this is an exact differential equation, there exists a function f of x comma y such that there is going to be solution to this differential equation. Now, how do we go about finding that function? So, you know that p of, according to our assumption, p of x comma y is nothing but partial derivative, first order partial derivative of that function f with respect to x, right? So now, if we take the integral of both sides, we are going to get integral p of x comma y dx is equal to integral del f del x dx, and that is going to be your f of x comma y. So I could say that f of x comma y is equal to integral p of xy, which is just this, right? 3x square y minus cosine of x dx. Now let's go ahead and simplify it. F of x comma y is going to be, I'm going to do this integral in one step. So y is going to be a constant because we are going to be taking integral with respect to x. So it's going to be y times 3 times x cubed over 3, because integral of x square is x cubed over 3 minus integral of cosine of x is nothing but sine of x. Now we have to add an arbitrary constant here. Let's call it g of y. Remember, we are taking integral with respect to x, so it's not an arbitrary constant, but rather it's a function, by the way. So let me clarify it. So g of y is a function of y, is going to be serving as a constant because we are taking integral with respect to x. Now let me go ahead and simplify it further. So f of x comma y is going to be 3 is going to cancel out. That's going to give me x cubed times y, then minus sine of x plus the function of y, g of y. Now we are going to go ahead and try to find the value of g of y. How do we find g of y? There is a way to do so. Remember, our function f of xy, we kind of in theory found it. However, the partial derivative of f with respect to y is nothing but q of x comma y. That is what it is. So right here. And we know that thing, which is x cubed minus sine of y. So let's go ahead and take the partial derivative of f with respect to y, which is, by the way, is going to be partial derivative of x cube y, which is going to give me just x cube. And the partial derivative of this guy with respect to y, sine of x, is going to be 0 plus g prime of y, because we don't have the explicit format for g. So it's going to be x cube plus g prime of y, and that, by the way, is going to be equal to this guy here, x cube minus sine of y. Now I could subtract x cube from both sides. Okay, that is going to give me g prime of y is equal to negative sine of y. Now I could integrate g prime of y with respect to y. If I do that, it's gonna be integral g prime of y dy is equal to integral negative sine of y dy. Integral g prime of y dy is gonna be nothing but g of y, okay, and that is equal to negative integral of sine of y dy. That's gonna be negative cosine of y, which is going to be just cosine of y. So I could take this g of y is equal to cosine of y and plug it into this equation. So that gives me f of x comma y is equal to x cube y minus sine of x plus cosine of y. So your general solution for this exact differential equation is going to be nothing but f of x comma y is equal to x cube y minus sine of x plus cosine of y, and that is equal to some arbitrary constant c. So this is how you'd solve an exact differential equation, and this is how you find the final solution to this differential equation. Technically, you are not going to have an explicit solution. It's going to be sort of an implicit solution in terms of combination of x and y, etc. You're not going to get something like y is equal to y of t, more than likely, right? So, but we have an equation that is actually a solution to this exact differential equation. I hope that this discussion was helpful. Thank you very much.